we're going to do two things. We're going to find arc length, the distance your fingertips moved in space over that number of degrees or radians, and also the area. So the arc length is pretty easy. Arc length is referred to as S, arc length, so the variable we use is S, and then theta is your number of radians. Now, radians correspond to radii, so they correspond to length and area. Degrees do not. You have to convert to radians or it won't work. You'll just get a wrong answer. You'll think you're doing it right, but it's wrong. And then what do you think this R here is? Radius of a circle. Now, no way can I just circle. I can just prove this for you in like 2 minutes. No way. Yes, I can. All right. Do you know what a ratio is? Comparison of two things, like height to weight, right? But a proportion are two ratios that are what to each other? They're equal to each other. Like 1/2 is to 3/6, or 1/4 is to 2/8. So those are two equal ratios. That's what a proportion is. Well, we're going to form a proportion, and I'm going to take the number of radians, theta, and how many in a full circle? This is little theta here. How many radians, and you did this already, 6 2/7 we refer to as 2 pi. So write that down somewhere. Theta is to 2 pi. So this angle is to the whole arc length around as an arc length S. So here's my little S here, just a part of this, compared to the distance all the way around a circle. What's the circumference of a circle? 2 pi r. So theta is to 2 pi as the arc length is to 2 pi r. And notice a lot of things are going to cancel. The 2's will cancel. The pi's will cancel. And so if I cross multiply, I'll get theta times r is equal to S. And that's the formula that I mentioned. Okay? So S is r times theta. If you have an example, r is 5 and theta is 30, this is going to be 150 meters, right? No, it's not. Why not, Annabelle? Yeah, it doesn't even make sense. Think of 30 degrees with your arm. Let's say your arm was 5. Let's say you had Jace's arm. Just kidding. But it's 5 meters long, and you went 30 degrees. There's no way that's going to be 150 meters. That doesn't even make sense. That's why degrees don't work. So we have to convert it to radians. And so what you do is you say 30 degrees multiply by, which one is it? 180 over pi or pi over 180? Good, pi over 180. And then you could figure out what that is. That is pi over 6, by the way. So it's going to be 5 pi over 6 meters is the length of that arc. And you could calculate it to a decimal if you wanted to. Okay, now this second one's easier. S equals r times theta. This will just be 5 meters times theta, which is already in radians. We can multiply by that, and this will just be 3 pi meters for your answer. So we like it when it's already in radians. You don't have to convert. And the reason you have to convert is because degrees are what? What are degrees? They're made up. Okay? Degrees are made up. They are not real. They're not correlating to anything in the reality other than we like the number 60. All right, next one. So we're going to find a sector. The best, this illustration, I like to put pictures up, but this really shows what a sector is if you take somebody in the snow and then you make snow angels, those are how many sectors are they making? 4, one for each limb. But you can really see this sector. Here's theta, and then here's the arc length out here, and then there's the area in between. So how do you prove this? Hey guys, How do you prove this? What you do is the same thing as we did before. I'm going to take the angle theta. Here's your theta. And I'm going to compare that to 2 pi to go all the way around the circle. Then the area of the sector, I don't know what the area of the sector is, but I do know what the area of a circle is. What is the area of the circle? No, that's not right. You said pi r squared. No, pi r round. Okay, you got it. All right. That's my grandpa's favorite joke. Pi r squared. Okay, good. So if the theta is to 2 pi, we have this ratio equal to the ratio of area of a sector is to area of a circle. Then what happens are the pi's cancel out. And so what you'll be left with is area of a sector is equal to r squared theta over 2. And that's the formula for area of a sector. R is the radius of the circle. Theta is the number of radians, again. And then 2 is 2. Yep, and that cancels out. That's kind of what I was leaning toward there. So now, once you have that, you should be able to figure out the area of a sector. So like this one here, for example, the area of the sector is 1/2 r squared theta. By the way, I wish my HL2 students could remember this day because we use this when we calculate the area under a curve in calculus. We use this formula 2 years from now. And so try to remember this one. If you don't, I'll remind you of it, and I'll remind you of our sector day and your M&M day. I'll remind you of that. But 1/2 r squared theta is how you find that area. So 1/2 r is 14 centimeters, and theta is 5 pi over 3. And whatever that simplifies to, you can do that. I haven't, yes, have I shown you the calculator yet? Here, let's do the calculator with this. So ignore the pi, because the pi is irrational. You have 14 squared times 5 divided by 2 divided by 3. And then go math frac. That'll simplify everything down for you. So you get 490 over 3. And so you would say this would be 490 pi over 3 units, centimeters actually, squared. Not nice? I like the calculator. Makes everything easier. So for the first one, R is 10 units. I don't know what units are for this one. Now, you could put 30, but the problem with 30 is not in radians, and it'll throw everything off because degrees are made up. So we're going to multiply by pi over 180, which turns this theta into pi over 6. So then you just go S is equal to R times theta, and area is 1/2 r squared theta. So you're going to have S is equal to 10 times pi over 6, which is just 5 pi over 3 units. And then this one is going to be 1/2 10 squared times pi over 6, which is going to be 50 pi over 6 units squared. And you could 25 pi over 3, couldn't you? Units squared. Did anybody get 25 pi over 3 for that one? Good. And then this guy, you're going to have 2 times theta is going to be 5 pi over 6. If you figure that one out. So the arc length is going to be 2 times 5 pi over 6, which is 5 pi over 3 units. And then area of a sector is going to be very interesting. I did not do this on purpose. 1/2 times 2 squared times 5 pi over 6. These will turn into 5 pi over 3 units squared. So that's pretty cool that that happened. And that is the area of a sector and the length of an arc length.